Hello, everyone. This is Kyle Welch with RCR Wireless News. I want to thank everyone for attending today's webinar, Interference Hunting Tools, How to Choose the Best Tools to Quickly Accomplish This Difficult Job, presented by Anritsu. Our presenter today is Eric Hokanson, Senior Product Manager at Anritsu, and helping him out with the Q&A at the end will be Thomas Elliott, Senior Product Manager at Anritsu. At this time, I'd like to pass the presentation over to Eric.
Thanks, Kyle. This is Eric Hokanson, and I'll be doing the presentation today. And we'll start off with an agenda, just reviewing what we're going to talk about. We're first going to review the interference hunting process. We've got another webinar on this we did some time ago, but it's a good review to make sure we know what we're talking about. And then we'll go through the different steps and what tools are optimal for each of those steps, starting with switch statistics. We'll talk a lot about Spectrum Analyzers. That's really the key tool for this task, both specs and functionality. A little bit about PIM, passive intermodulation, both seeing indications of that as well as making accurate measurements of it. We'll talk about interference hunting with vehicles with our mobile interference hunting system, as well as on foot with the handheld interference hunter. And then a bunch of accessories, antennas, filters, other accessories, support tools like this webinar, as well as other documents. And we'll spend about 20 minutes or so on Q&A at the end. So the process, that's our review again. First step is to know that you've got a problem. If it's not broken, you don't really need to fix it. And there's several ways to do that. We'll talk somewhat about switch statistics, but it also might just be customer complaints if there's a problem. Next step is seeing what the spectrum looks like on a spectrum analyzer. That's really a good clue about what the signal is and where it is and what to do to find it. And from there, we estimate the position to give us an idea of where to go, travel that estimated position, and then start refining that estimate until I can park my vehicle. Then I get out and use a handheld system to go find the actual emitter. As I mentioned, we've got a separate webinar on this very topic, and there's a link to it right there. Okay, let's talk about switch statistics. That's, as I mentioned, the first step to know you have a problem, and that can be what are called KPIs or key performance indicators, things like blocked calls or drop calls, a call that's running and then gets stopped in the middle. I've seen systems for public safety say things like illegal carrier from the monitoring system. That's another switch statistic type thing. I've even seen in some systems indications of received power level or even down to the resource block level in LTE. It's kind of a crude spectrum analyzer by itself, which can be a little more information about what's going on. And another piece of this is comparing adjacent sectors and nearby cells, which can give you some clues about approximate location, which can help you travel in the right direction. And Kyle, we're going to do our first poll now. Okay, let's talk about spectrum analyzers. It's really the basic tool for understanding spectrum. Shows a picture of power versus frequency, or sometimes power versus time can be useful. And a really interesting tool is a spectrogram, where you see power versus both frequency and time. We'll show some pictures of that briefly as we're talking about different tools. Often we use different tools along with a spectrum analyzer, at least antennas, but a number of other things as well. And sometimes there are receivers that have similar functionality as spectrum analyzers, but they usually have somewhat lower RF performance. So let's talk about specs. What makes for a good spectrum analyzer? And we'll specifically talk about what makes for a good spectrum analyzer for interference hunting. One of the most important aspects is the noise level. What usually shows up on a data sheet as DANL, or displayed average noise level. But closely associated with that is dynamic range. We'll talk about both of those a little bit. And then a multi-step attenuator can be really useful along with dynamic range. We'll briefly talk about that. A number of other interference hunting tools can make your job easy. Things like accessories, support from the company you buy the equipment from. And I have a brief comment about Amplitude Accuracy as well. So let's talk about DANL. It really helps you see small signals, and interfering signals can be quite small sometimes. I have a little analysis later that makes it really obvious what's going on there. It also lets you sweep faster because you can use a wider RBW resolution bandwidth when looking for a CW signal, which lets you see signals farther away, like from the base of a tower. when we see our analysis, we'll see what I mean by that. A good spec for that is minus 160 dBm per hertz, typical. And we don't really need to make accurate measurements here, so typical specs are pretty useful. We're trying to get an indication of where the emitter is. That spec is usually in a 1 hertz bandwidth or normalized to 1 hertz because noise varies with bandwidth. I get more bandwidth, I get more noise. And the reason, minus 160 dBm sounds like a very, very low level, but then when you translate that to dBm per megahertz, like a whole channel somewhere, that's only minus 100 dBm. That's pretty close to the sensitivity of many phones. So that's why we need to have good sensitivity there. Closely associated with noise level is dynamic range. We could have a whole other webinar on this, and we'll briefly cover some of the aspects. But the idea here is that we can see small signals, but now in the presence of big signals. And this happens a lot out in the real world. So the instrument spec of DANL is obviously pretty important because that's the low end. But the major contributor to the high end of dynamic range is the distortion, how much distortion the instrument itself causes. And usually the dominant distortion is the third order distortion, which is why there's a spec for third order intercept. That's an indication of how good the distortion of the instrument is. A bigger number is better there versus for noise level, a low number is better. So if there's a spec for the instrument for dynamic range, it's important to know what methods are being used. There are many different methods that can have wildly different numerical values. I like the method listed here, 2/3 of TOI minus DANL. That's a real usable distortion dynamic range metric. Some metrics are really pretty silly. If that number is more than 100 dB, that starts to be a pretty good analyzer. That's with a 1 hertz resolution bandwidth. So again, that varies with resolution bandwidth because the noise does. And here's an interesting aspect. When you turn a preamp on an analyzer, the noise floor gets better. We're talking about that on the previous slide. But the distortion gets worse faster than the noise gets better. So it can actually reduce dynamic range. And we'll see some ways that we can ameliorate that problem with filters in a little bit. And I have some other slides on other limitations and what to do to improve dynamic range. I'm going to breeze through these pretty quickly. It's not really the focus of this webinar, but they'll be in the slides later if you want. You can look at them in more detail. So why are the dynamic range and DANL so important? You'd think that if there's an interfering signal, it has to be big, so it's big enough to cause a problem. It should be easy to see, right? Well, we're comparing a cell site antenna, for example, with an analyzer maybe on the ground. And so our cell site might have a really nice antenna, maybe as much as 25 dB gain, with a preamplifier mounted right next to it with 1 dB noise figure. That's really good. And Spectrum Analyzer doesn't have near as good noise figure as that because it's broadband. The tower mounted preamp can be narrow band. It can be really optimized for noise figure. And then that antenna might be way up in the air, maybe 30 meters. So the path loss to the emitter might be really low because there are no buildings in the way. And if I don't have a good indication of where to start my interference hunt, I might start at the base of the tower. Well, all of those advantages I just talked about are lost. That might be 25 or maybe even as much as 50 dB disadvantage compared to what the cell site's doing. So that big signal for the cell site suddenly becomes a very small signal. And worse yet, I've got a very large downlink signal nearby, which can be a problem for the dynamic range of the analyzer. Just briefly, some other limitations on dynamic range: phase noise for close-in signals, spurious signals in the analyzer, and then radiated emissions in the attenuator settings. Radiated emissions, we talked about this in spectrum monitoring about a month ago in another webinar. One of the things to be aware of is that spectrum analyzers have digital hardware in them too. They have clocks, and so they actually radiate at some frequencies. So when you mount an antenna right on the analyzer, you're really good at picking up the analyzer radiated emissions as well. So if you run into a situation like this at one of the frequencies for a particular analyzer that's a problem, often just using a cable so you can move the analyzer away from the antenna fixes that. Directional antennas help as well. Here's a complicated slide on the instrument settings, some of the trade-offs you can make for getting better dynamic range. I won't go into the details here. You can look at the slides later. Accessories, we'll talk a lot more about these, but in general, antennas, especially antenna gain, can be really helpful. And the directionality of a directional antenna can help you point away from large signals. Filters can help eliminate large signals before they get into a preamp and cause intermodulation. Maybe even external preamp, something that's more optimized for noise figure, such as in the handheld interference hunter, the MA2700A, might be 5 or 10 dB lower noise than in the analyzer. We'll talk more about those later. Here's some examples of optimum settings. If I've got an MA2700, there's a set of settings there. Again, you can look at these later. To get 5 dB lower noise, I can change the settings a little bit. The dynamic range isn't as good, but I can look a little bit lower. And on my analyzer at my desk, we can see in the first case, I get 4 dB better than my typical spec I talked about earlier, -164. And then the optimized for noise case, I get even 5 dB better than that, -169. Let me talk a little bit about amplitude accuracy. There's some people in the industry that talk about how important amplitude accuracy is for interference hunting. And when I heard that, I just started laughing because you've got an antenna that's out in space. And if I move that antenna even just a few inches, I can get a very large change in amplitude because of multipath. So a good indication that the analyzer is stable and has reasonable accuracy is if it's, maybe 1 dB typical. If it's 5 dB, it's pretty bad. But if it's 1 dB, that should be more than good enough. Okay, so much for spectrum analyzer specs. Let's talk a little bit about capabilities, things that are done on the analyzer to help make your job easier. Starting with being battery powered when you're walking around on foot, that's really helpful. Makes it much easier to find the emitter. But things like ergonomics, like what's done for carry straps. And there's a picture there of one of our colleagues walking around with a handheld instrument with a carry strap wrapped around his neck and back. And it's held in close to him. He has at least one hand free at all times. There's also a strap on the MA2700 that's holding the antenna, so you can actually have both hands free. Things like getting out IDs or opening doors, adjusting the instrument, that's all really handy. I mentioned previously that a spectrogram is really helpful for understanding both frequency, power, and time. And there's an example there of a signal that's bursting on and off occasionally. You can see what the timing of that signal is, and also what frequency it is. Other useful things are variable attenuator for optimizing dynamic range of the instrument with the signals, variable resolution bandwidth and video bandwidth. That helps you make the optimum trade-offs for the dynamic range of the instrument compared to what you're looking for. And as part of that, having overload indicators in the instrument that tell you when you set things wrong and you might be getting bad answers are really helpful, to the point of almost being critical. The picture at the bottom there is a case where the signal's too big and the instrument's saying, okay, the signal's too big for the analog to digital converter, the way the instrument's set up. And then it tells you what to do, increase the reference level. That'll help fix the problem. Some other useful spectrum analyzer capabilities are tools for looking for bursty signals. This is a real problem out in the field, kind of like intermittence when you're trying to fix a piece of electronics. The kind of basic one there is max hold, and it's really helpful. You can have the analyzer sit for a while and see what the maximum signal is over time. A counterpoint to that is actually min hold, when I have a static signal like CW, but then I have it maybe in a frequency where there's uplink traffic that's bursty. And if I'm just looking at it on the analyzer, it's hard to see the maybe small CW signal. But if I use min hold, that bursty signal goes away and the CW signal remains. And then there's burst detect that's available in some of our analyzers. That's a really cool version of max hold. It runs really fast, up to 20,000 traces per second. Does max hold on those, and after the end of a sweep, when the display updates, it resets and starts over. So if I'm moving a handheld antenna around, I can see the amplitude of the signal change while I'm capturing narrow bursts. Some other capabilities are other interference hunting tools like mapping on the analyzer. Maybe I'm walking around by hand, or maybe even in a vehicle sometimes. A level meter and a level tone to tell you what direction the largest signal is, which is usually a good indication where the emitter is. accessories like antennas and filters. We'll talk more about those. And coverage mapping sometimes. There's occasions, especially indoors, when there's so much multipath that you can't get a good bearing. But there's still free space loss. So if I can, say, walk around inside a building, I can keep track of what the signal levels are. I can get an indication of where the emitter is. Also, it can be handy to have tools for related tasks, things like accurate power level, maybe modulation quality of transmitters, maybe doing line sweep. These have nothing to do with the interference hunting process per se, but the same person might have different jobs on different times of the day or different days of the week. And having those tools available means you don't have to have multiple boxes in your truck. And then there's a bunch of support tools like webinars, app notes, and field application engineers. We'll talk some more about those later. More capabilities, tools for monitoring spectrum when you need to get a better picture of maybe when something's happening. Maybe it only happens on weekends, for example. So a spectrogram with recording can keep track of what the signal looks like over time. Related to that is a save on event, where the instrument just records the signal. Or maybe you have a limit mask when a signal gets too big. You know that the signal is normally small, but occasionally it's big. You can only record those big signals. Makes it a lot easier to see it in the spectrogram. And with a PC tool, we can actually make a spectrogram out of those recorded traces as well. Being able to record or control the instrument remotely can be really handy, maybe at your desk, and have a spectrum analyzer out in a cell site, for example, and be able to see what's going on live and actually adjust the analyzer as you discover different things about what's going on. We have a whole separate webinar on this topic as well, again, with a link there. PC tools, I mentioned analyzing spectrograms at your desk. This can be really handy for looking at large spectrograms with a large display and a fast processor, or even seeing the spectrogram in 3D or turning the spectrogram into an AVI file and watching it play over time. And here's an interesting one. Having a night vision display on the analyzer can be handy. And at first you think, well, why would I need that? Normally, you know, I've got plenty of light around. I don't really need to worry about that. Well, you might be in a location where you don't want your face bathed with a bright analyzer display. Maybe not the best part of town, for example. So that's one of the reasons that's in our handheld analyzers. Okay, so much for spectrum analyzers. Let's go back to the process. Remember, we had switch statistics. The next step is to check what the spectrum looks like at the base station to see what it looks like. And this can provide some good clues about where the signal's coming from. So first we see that the noise level really is high. It's not a problem with the switch statistics themselves. We can see what the spectrum looks like that the base station receiver is actually seeing, ideally from a test port if you can get that. Looking at the spectrum itself can be some hints to the cause. Frequency, spectrum shape, you know, is it a CW signal? Does it look like PIM? The picture there is cable TV leakage with a clear 6 megahertz BART fed kind of display. And the slope off to the left is the base station receive filter up in the tower mounted amplifier. You can also see variations over time, maybe what time of day or what day of the week the signal's causing a problem. And you get a picture, and so when you're out in the field, you know what to look for. And you can also get some hints to location here, looking at the relative power in different sectors. So say you've got a sector pointing north, and it's got a nice big signal, and the sector pointing to the southwest is maybe 20 dB below that. The sector pointing to the southeast is maybe 10 dB below the north pointing sector. So you know the signal is maybe to the east of north. It gives you a little clue about what direction to go. It's not a super accurate measurement, but it's a good hint. Okay, let's talk a little bit about PIM. When we're talking about interference hunting, normally we're looking for signals out in the field, but sometimes the interference can come from the base station itself or maybe something right next to the base station. So passive intermodulation is where the signals from the base stations combine together to create another frequency. And this can be internal to the cabling or might be external. With a spectrum analyzer, you can get an indication of the PIM. You don't really know exactly what's going on because you don't have exact control over the power level. But you can see that it's there and then it might be a problem. And oftentimes you'll then call a crew out with a PIM analyzer to measure what the level really is, as well as fix the problem. There's also a test script for a tool called EasyTest, we'll talk a little bit more about later, for Anritsu handheld analyzers that makes this PIM indication measurement a little bit easier. Okay, if we've got an indication there's PIM, or maybe we're doing some preventative maintenance, we can do PIM measurements. We've got a picture of an Anritsu PIM analyzer in the lower right corner there. This lets us actually measure the different lines and do something called distance to PIM, where we can find where the PIM is coming from. One of the indications of that, it can be really handy, is internal versus external PIM. Is it in the cable antenna system, or is it something outside, a rusty bolt, for example? And then the other part of actually doing a measurement is verifying the result, because I have controlled conditions with known power levels of CW signals. And I can set a threshold that says, okay, at this level, I know that it's good. When I'm getting just the indication, it's like, well, maybe there's a problem, but I don't know if it's really good or bad, and it maybe varies with time or with traffic on the cell site. Okay, moving into tools to use along with the spectrum analyzer, and we're going to talk about our mobile interference hunting system. This is a tool that makes it easier to drive to the location of the emitter, the parking lot close to the emitter, quickly. Keeps track of the power levels and looks at the probability of where an emitter is based on that, and will even give you voice prompts about where to turn and the approximate location of the emitter. That system has tools for various kinds of interference signals, including modulated signals, noise or jammers, bursty signals, we talked about that a little bit earlier, as well as for ignoring uplink traffic. And usually interferers in the uplink are the biggest problem. Sometimes they're in a guard band, they're easy to see, but sometimes they're right in the middle of the uplink spectrum. And you really need a way to get rid of that uplink traffic to be able to see the emitter. Some things to think about here, the ease of use of the system, how easy is it to set up, how simple and clean is the interface. You don't want a lot of clutter, especially when you're driving around. A nice large map so you can see where you are and where the estimated emitter position is. Some things to really think about is this safe for one operator, or do I need multiple people? That could be a big cost if you have to have 2 people instead of 1. So things like voice prompts that tell you where to go without having to look at the map all the time, a little dangerous when you're driving, and maybe having the map automatically centered so that you don't have to be adjusting the screen. Some other considerations, is there a way to record the hunt so that I can do further analysis later? Sometimes I'll have problems where I can't find the emitter, but I can go back to the office and talk to one of the experts, and they go, oh, well, you need to do this and look over here. And then again, maybe being able to reuse the analyzer for other tasks when you're not doing an interference hunt. Maybe the spectrum monitoring part, or maybe I'm using it for the on-foot piece. I use one analyzer for the driving around. Maybe I can use the same analyzer for the last step. And maybe I can use the same analyzer for doing base station maintenance. That can be really handy if that's part of my job. Okay, Kyle, we have our second poll now. Okay, talking about some other tools. We talked about our mobile interference hunting system, and now we're going to talk about our handheld interference hunter, an Anritsu MA2700A. That's really the handle that's connected to the antenna in the picture here. That's a nice aid for the on-foot part of the process step. Because of the ergonomics for carrying the antenna, it's got a shoulder strap so you can take your hand away and do other stuff with it, again, like opening doors or whatnot. Also has a GPS receiver built in for when you're using it for taking bearings. A little easier than maybe putting a cable on a helmet on your head or something. Also has a compass for taking bearings, electronic compass, as well as a preamp, a little bit better noise figure than what's in the instrument. There's also a trigger under the left hand of the operator there, under his forefinger, for taking bearings. You figure out the angle that's the biggest signal, you can push the trigger and the bearings automatically recorded. It's integrated with the mapping function on the spectrum analyzer as part of the interference analysis option. And that can be really helpful. You know, mobile interference hunter is great, but sometimes either you don't have one or you're in a place where it doesn't work, like there are no roads, for example. So you can do triangulation as shown here, or you can just home in on the signal, just keep moving towards where the largest signal is. Let's talk a little bit about antennas. There's actually a bunch of reference slides here for your future reference, but we'll just talk here a little bit. The key point here is that all antennas have trade-offs. So you have to pick the best one for your application. And we could do another webinar on this very topic. So there's 4 types of antenna listed here. This is not a comprehensive list, but it's a good overview of types that are commonly used for interference hunting. Yagi antenna, the top one there in the pictures, has really good gain, 10 dB or more oftentimes, but they tend to be narrow band. So if you work at multiple frequencies, you need multiple antennas. Log periodics are broadband, but they only have moderate gain, maybe 6 or 7 dB, and they may be physically large, especially for lower frequencies. The biblade, the next antenna, the third one down there, is similar in performance to the log periodic, kind of backwards a little bit, with a bigger part farther away from you. Turns out that integrates very nicely in with the mobile interference hunter. It fits nicely under the handle, and it has some ears to take the torque on the antenna. Some other pictures of that we'll see later. Its limitation is that it has moderate front-to-back ratio, although there's some ways to deal with that, especially using the operator's body to shield the signal. And then loop-style antennas are usually for lower frequencies, like 500 megahertz and below. They tend to not be terribly directional, but they're much better than an omni antenna. In the next several slides, I'm just going to breeze through that has more details about each of these antenna types. So here's a Yagi. Notice the 10 to 14 dB gain and the narrow beam width shown in the picture. Log periodics, broad bandwidth, but 4 to 7 dB type of gain, much broader beam width. Here's the biblade. It has kind of intermediate, a little bit better than a log periodic, maybe not a lot, a little bit. Not quite as wide bandwidth, but covers all of the main cellular bands and integrates nicely with the MA2700, as you can see in the bottom picture there, where those ears fit into little tabs on the handle. Biggest limitation is poor front-to-back ratio. Loop-style antennas tend to be for 500 megahertz and below. We have a couple of those available too. Okay, Kyle, third and last poll. Okay, let's talk a little bit about filters. Remember I was talking about how preamps can reduce the dynamic range. Well, one way to get that back is with a filter before the preamp. This can help eliminate the large signals, leave the small signals that you're looking for, and you can turn up the gain with the preamp. So we have a number of filters available. We have a line that's integrated with the MA2700 in the upper left picture there. Those are really nice being small and integrated, but they don't have the lowest loss or the sharpest response. That you get with a cavity filter like in the lower left corner. Those are a little big for carrying around on foot, but if you're using it in a vehicle, those can be quite useful. Or maybe use the same filter for both. Again, there are more trade-offs: size, weight, insertion loss, stop band rejection, the sharpness of the filter. Lower right's example low-pass filter. We also have a line of high and low-pass filters that can be used mostly in the public safety bands. And again, there's another slide here that has a bunch more details that you can look at your leisure if you wish. PC tools can be really helpful. We've got a number of tools available. One of them is master software tools. I mentioned seeing large spectrograms before. You can also turn those into 3D spectrograms, like the upper left picture there. You can also turn them into an AVI file where you can watch how the spectrum evolves over time while sitting live at your desk, and a bunch of other things as well. Easy map tools are for downloading maps into the instrument. We saw some examples of that earlier when doing mapping on the instrument. And then easy test tools I briefly mentioned. That's a tool for creating test scripts. That's not so applicable to interference hunting per se, but it is useful for some of the other things that you might be doing with the analyzer. Other accessories, a bunch of things to make your job easier. As we mentioned, this is a pretty difficult job, and anything you can do to make your job easier is a good thing. So things like transit cases to make sure that expensive test equipment doesn't get beaten up. Spare batteries when you're out in the field and battery runs out after a couple of hours. There's a monopod for the MA2700. It's a little useful for stabilizing it, but what it's really useful for is lifting the antenna up to be closer to, say, lines on cable TV lines on telephone poles. We've got several mag mount antennas and a bunch of omnidirectional antennas as well. We also have a wide variety of support tools. These can be really helpful, just like we're doing this webinar now. So videos, webinars, app notes, articles, troubleshooting guides. In fact, Tom Elliott, sitting next to me here, wrote this very nice troubleshooting guide on interference hunting that I highly recommend, as well as white papers. We even have a class where you can get certified in interference analysis. So in summary, we talked about a lot of stuff today. That's because there's lots of tools to help find interference. An important thing is guidelines for picking the optimal tools, the best one for your job. And we've got lots and lots of ways that we can help. And that's it for the webinar. And we can open it up for Q&A now.
All right, thanks. Thanks, Eric. This is Kyle again. We had a number of questions come in, and again, I just encourage everyone in the audience to submit your questions via the control panel. First question we had come in, Eric, is what tools would one use to hunt for interference?
Well, like we talked about, really the key tool is the spectrum analyzer for being able to see what the signal is. And then along with that, antennas and filters for being able to see the low-level signal, being able to see the signal at all, the antenna. A filter helps out with low-level signals. But then there's a bunch of things that can make your job easier, like our mobile interference hunting system to help you when you're driving, and the handheld interference hunter for helping you when you're walking around.
All right, thanks. And we actually have a couple follow-up questions similar to that. So how does one deal with interference in a DAS system, a distributed antenna system?
Yeah, that's a good question. It's a very similar process, but there's some things that might be a little bit different. So, for example, oftentimes DAS are inside buildings. That makes it difficult to, say, drive a vehicle around, and maybe difficult to get good bearings. But maybe doing just homing, or in the complicated cases, doing what's called coverage mapping, where normally you think of that as, the coverage of the base station downlink signal, but you're looking to do a kind of a similar map for the interference signal to find where the highest amplitude is. Tom, do you have any other comments about that?
As far as tools?
Yes.
Interference hunting tools, I think Eric's covered it pretty good. On the other hand, there are also a variety of spectrum monitoring tools you can use to find out when you need to go hunting the interference. I'd like to start with the switch statistics that Eric mentioned, and one of our correspondents mentioned as well. They can give you a lot of clues as to when the problem is occurring. In addition, there's a variety of spectrum monitoring tools and remote monitoring tools that Anritsu has that can assist with this.
Okay, great. So kind of the other portion of this question is how does one hunt for interference in an LTE system?
Again, it's pretty much the same process, but when you talk about a specific system type, there's more things we know about, so there's more details, for example. So LTE, usually the biggest problem is in the uplink, because when you have an interference problem, it takes out a whole sector versus maybe taking out just a local location. So most of the work goes into uplink interference problems. The uplink signal, as we mentioned briefly, is bursty. That's to save the battery power in your UE or handset. And if your interference signal is in underneath that, it can be very difficult to see. But having min hold that you periodically reset can be a really good way to do that. It turns out our mobile interference hunting system does that automatically. You can set it up for uplink type signals, and it'll do min hold for a few seconds and then reset it and start over again. It makes it a lot easier to see those signals underneath the bursty uplink traffic. But other than that, the process is pretty much the same. Start with switch statistics, look at the spectrum, travel the location, find an optimal parking spot, get out on foot, and either triangulate or home to find the actual emitter.
All right, great. Next question coming in from the audience is, does an interferer need to be identified first with a spectrum analyzer and then used as an input for the mobile automobile tools?
So you got to know what you're looking for. If you just start driving and don't know anything about the signal, you don't really know where to tune the spectrum analyzer to look. So knowing what the frequency is, knowing that when you're out in the field yes, that's the signal, it's the same one that I saw at the base station. Those are really helpful, both for setting up the analyzer for using the in-vehicle tools, but also for just knowing that you found what you were looking for.
All right. When it comes to identifying source, particularly for a spread spectrum source, what are some of the best methods and tools that you know of?
Spread spectrum sources are tough. CW is a lot easier because I can crank the resolution bandwidth down on the analyzer and get a really low noise floor. But spread spectrum signals, as the name implies, spread the power over a wider frequency band. So one of the things is to get enough antenna gain and low enough noise floor in the spectrum analyzer to be able to see the signal at all, and then using channel power to integrate the power over the entire spread spectrum signal to give you an indication of how big the signal is as I'm moving around or moving my antenna around. And again, the mobile interference hunting system lets you do channel power, for example. And then when I'm walking on foot, I can use the resolution bandwidth control on the analyzer for setting that similar to the spread bandwidth of the signal.
Great. So what would be the best Anritsu tool for looking for interference?
I have a joke with my wife. It's kind of ongoing. It's the correct answer to any non-trivial question is, it depends. And the word best really implies, well, best in what way? So best could mean lowest cost, for example, or highest performance. We have a range of tools. We have lower cost tools and higher performance tools. The higher performance tools obviously are somewhat better, but they cost more. So for example, from a spectrum analyzer perspective, the MS2720T is our premier handheld spectrum analyzer product. From a performance perspective, it's really the best thing that we've got. Close to that, we're talking about being able to use the same tool for multiple tasks. The MT8220T base station analyzer is really a universal tool that lets you do all those other jobs like line sweep, for example. On the kind of low cost perspective, an MS2711E it's a pretty good handheld analyzer, a little bit lighter than a 2720T. Almost as good performance, not quite as good. It doesn't have burst detect, for example. Noise figure is not quite as good, but it's lighter and less expensive. So depending on your needs, you can make trade-offs of what's really the optimum thing for your particular case. And then, of course, there's all those other tools like filters and antennas and the mobile interference hunting system. Again, that depends on your specific needs. What frequencies are you looking at? So what antennas can you use or what filters make sense? Do I even need to worry about driving around, or am I only working inside a building, for example?
And we kind of had a follow-up question to that. So what are the big differences in using, say, the MA2700A versus one of the E models in the Anritsu line?
So the MA2700 is an accessory. The E models, like the 2711E I mentioned, or 2712, 2713E, are spectrum analyzers. The MA2700 works with all of our handheld spectrum analyzers. And it's really a handle for making it easier to carry antennas, along with having the preamp, GPS receiver, the carry strap for the ergonomics. So it's really an accessory class. I call those, complementary products to each other.
All right, great. Kind of the next question we had is, what are some of the best ways to compensate for multipath effects?
Multipath, the bane of anybody working out in the field. So what we're talking about here is that when you have a terrestrial environment like we're talking about, that the signal can bounce off of various things like buildings or hills or even airplanes. And those multiple paths the signal takes to get to a particular point in space can sometimes add together and can sometimes subtract from each other. So as I move an antenna a little bit, I can get a very different signal amplitude. So one thing to do is, as I'm trying to find direction, I might take a step in left or right, front or back, to see if the signal amplitude changes by a lot. that can be a really good indication that I was in a null or moved to a null. You want to get to a spot where the multipath is pretty random so that I'm getting good indications of where the power is as I'm rotating the antenna around. So basically kind of doing some kind of peak finding or averaging. The mobile interference hunting system, for example, as you're driving around, will average the power over a short period of time to average out the effects of the multipath.
Thanks. Next question we had come in. Does Anritsu have any spectrum analyzers that use FFT to improve resolution for interference hunting?
So it turns out all of our handheld spectrum analyzers automatically use FFT when it's in the one of the normal sweep modes. I actually have a way to make it not do FFT, but that's very unusual. This helps speed up the process of doing the resolution bandwidth filtering and makes the sweep times much faster. Remember we talked about the burst detect mode? That's on the MS2720T and the MT8220T. That's an FFT-based process. That's the 20,000 traces are done using an FFT.
Great. So kind of asking more questions about the Anritsu line. Do the Anritsu tools interface with the PC to drive and locate?
Yes, there's two main interfaces, USB and Ethernet. The mobile interference hunting system, for example, uses a tablet or a laptop running Windows, often Windows 8 because of the touchscreen advantages there. And there's a USB connection to the spectrum analyzer for that. But for the spectrum monitoring case, where you're long distance away, you'd usually use Ethernet. You might have an analyzer mounted, a couple miles away in the base station, or could be across the country, across the world, as long as you can get an IP address for it.
All right. So in your experience, Eric, what is the #1 way to locate low signal interference?
So the low signal is often the biggest problem. If you can't see the signal, you can't really do anything to find it. So I think there's two main ways. One is trying to get a higher gain antenna. The more signal you can get in, the better the situation is for finding a low-level signal. The other way is doing a survey. You've got a problem, and it's got to be somewhere in the vicinity of the radio receive antenna. So just driving around and doing a survey, and eventually you'll see the signal. That can be slow, but it's also powerful. That eventually you'll get close enough to be able to see the signal. And if you can't ever get close enough, well, it probably wasn't a big enough signal to cause a problem. Now, of course, if I've got something that's a high gain receive antenna, that means it's pretty directional. That can give you a clue on where to start just from the standpoint of what direction it's pointing in.
All right. Next question coming in. Do the Anritsu tools allow for multiple RX antennas for improving compensation from multipath confusion?
So the question sounds like doing some kind of diversity. And no, we don't have a particular way to do that. It's so easy to move the antenna a few inches or a few feet that that's really not an issue. Tom, did you have a comment too?
Yes, and also the interference setting tool Eric's been talking about with the tablet is mathematically correcting for that as you travel. Essentially, every time the car moves a wavelength or so, you've got a new receive antenna.
All right, great. Thank you. So next question coming in. What is the best way to determine power in transmitters, such as an FM broadcaster?
There's one of those non-trivial questions again, because it says best. Well, the most accurate way is with a power meter directly connected to the output. It's been calibrated as a calibrated attenuator, for example. A lot more convenient if there's a test port with a known coupling factor. You can measure the power, again, with a power meter and then offset the reading. There's functions in the analyzer for this. You can offset the reading by the coupling factor. but those can be inconvenient sometimes. Say you've got a remote radio head that's 30 meters up on a tower. Now you have a problem of, well, I don't have any way to connect to it. So you have to go out in the field and measure field strength, maybe average over several wavelengths so you get a pretty good indication. And then you have to do some math to figure out, well, what does that mean is the actual transmit power? And that's complicated, but given the alternative of climbing the tower, it's maybe the only choice you've got.
Great. So we had a question come in, maybe through a use case or something. Could you discuss at a time when the need to identify the owner of interference would be needed?
Oh, yeah. So that's the step we didn't talk about is, so after you found the interference, you need to do something about it. So, for example, sometimes it's really easy. We had a case where there was a cable TV leakage signal driving around, and we found this cable TV amplifier that was clearly sending out a signal. Well, we knew what the local cable operator was. We just called them and said, this one at this location, this is the problem. There's another case. At first, we thought this was a PIM problem. Turns out it was a repeater pointed at a base station. It looked like, you move the antenna for the base station up toward the sky, the thing that looked like PIM, the interference would go away. You moved it back down again, you'd see it again. It's like, oh, okay, there's PIM in the system. And then they replaced the antenna, they replaced the feed cable. No, that didn't have any effect at all. Turns out, like a mile away, there was an antenna pointed right back at the base station. Whenever the base station was transmitting, that repeater was distorting and sending the distortion right back to the base station. So in traveling out to this location, it's like, where's this repeater come from? And talk to the people there, I don't know anything about that. So the building owner is ultimately responsible. You talk to them, and it's like, okay, this is your building, what are you going to do about this? And if it comes to that, you can call in the local regulatory body like the FCC, and they can eventually resolve it. Most people don't want to go that route, but occasionally that does happen.
So we had a question come in from a potential customer asking about the if your tools read in metric, for instance, watts per meter squared for field strength analysis.
I'm not sure there was a question there. Do they read in metric?
Yeah.
The question is actually more accurately, do we have watts per meter squared?
Oh, okay, yeah. So there's all of our handheld analyzers have a field strength measurement where you can specify a number of Anritsu antennas or your own antenna that shows what's called the antenna factor, basically how efficient the antenna is at picking up a signal. And that can be displayed in many different units, watts per meter squared, dB microvolts per meter. There's about 8 different choices, and the analyzer will calculate the conversions for you.
All right, great. I think we have time for just a couple more questions. So the next one, do any of the Anritsu analyzers have output to control external filters, such as the Ultra Q filter for high-speed on-the-fly readings?
No, we don't have anything like that. That's an interesting idea.
We do, however, have a wide selection of external filters.
Gotcha.
I might comment also that, in general, tunable filters aren't very good. There may be exceptions to that. Something that's mechanically tuned can be quite good. It can be a cavity filter, but of course, it has to have a motor on it or something for tuning it. Electrically tunable filters are usually done with varactors, and they tend to have a fair amount of distortion themselves. We've actually seen some receivers that tout that they have electrically tunable preselectors in them. And when we actually measure them, we find that the preselector distorts more than our analyzer does itself. So, okay, it's better with a preselector, but it's still not very good.
I'd like to point out the distortion you see in filters will show up as spurious signals that you might end up trying to chase. It looks like interference.
Gotcha. Okay. So next, do any of the Anritsu tools offer the ability to null out specific signals?
So the idea we talked about at min-hole is one way of doing that, of basically nulling it out by looking at the multiple traces and taking the minimum of all those. That works great for nulling out bursty signals. But for, say, a CW signal in a particular frequency, the best thing I could say there is just don't tune to that frequency. Tune to the frequency where you're looking for the interfering signal.
Okay. Finally, well, we have time for just 2 more questions. So the next one, what are your thoughts on log periodic versus Yagi?
It's one of those trade-offs. Log periodic, if I'm looking at a wide frequency range and I don't know what frequency I'm going to work at, is a good choice. It just doesn't have as high gain or as narrow beam width as a Yagi. So if I'm working on cellular, I might have 3 or 4 frequencies. A couple of Yagis to carry around isn't too bad. But if I worked for a regulator and I had no idea what frequency I was going to work at, log periodic is a better choice because I don't have to have hundreds of them.
All right, we've got time for just one more question. So, Eric, in your opinion, what is the best Anritsu tool for looking for low signal interference?
MS2720T with the MA2700 and the highest gain antenna you can get, probably a Yagi.
All right, sounds great. That's about all the time we have today. I want to thank everyone for attending today's webinar, Interference Hunting Tools, How to Choose the Best Tools to Quickly Accomplish This Difficult Job, presented by Anritsu. Again, our presenter today was Eric Hokanson, Senior Product Manager at Anritsu. And I also want to thank Thomas Elliott, Senior Product Manager at Anritsu, for helping out with the Q&A. Thank you, guys.
Thanks, Kyle.